Hello everyone, this is topic 3.7 Solutions and Mixtures. This is taken from AP Chemistry College Board. In this video, I'll be talking about what is a mixture and what are the different types of mixtures, what is a solution and how do we measure the composition of a solution. So let's start. Basically, the matter can be divided into two types. One is pure substance and another is impure substance. Pure substance is further divided into elements and compounds. We already know what are these, and the impure substance is further called as a mixture because it is formed of two or more types of substances. Further, this mixture can be divided into two types. One is homogeneous mixture and another is heterogeneous mixture. This homogeneous mixture is also called as a solution, and the heterogeneous mixture can be of two types. One is suspension and another is colloidal. So in this video, I'll be talking about mixture, homogeneous and solution. The types of mixtures are heterogeneous mixture and homogeneous mixture. In heterogeneous mixture, the particles are distributed non-uniformly. For example, if we take a mixture of sand and water, the sand would settle down. This means that this mixture has two phases. The homogeneous mixture is a mixture in which the particles are distributed uniformly, like you can see here. For example, if we take a solution of sugar and water, the sugar will be completely dissolved in water, and if we take 2 spoons out of this mixture, you can see that the composition in one spoon is same as the composition in the second spoon, and there is only one phase in this homogeneous mixture. Another name of homogeneous mixture is solution. A solution is made up of solute and solvent. So when some solute is dissolved in a solvent, it leads to a solution. The minority is a solute. There are different types of solutions. The solutions can be gaseous, liquid and solid. In the gaseous solutions, the solvent is a gas, but a solute can be gas, liquid or solid. The example of gas in a gas is mixture of oxygen and nitrogen gases. Liquid in a gas is chloroform mixed with nitrogen gas, and the solid in gas is camphor in nitrogen gas. In liquid solutions, the solvent is liquid and the solute can be again gas, liquid or solid. So gas in a liquid is oxygen dissolved in water, liquid in a liquid can be ethanol dissolved in water, and solid in a liquid can be glucose dissolved in water, or as we saw earlier also, like sugar dissolved in water. In solid solutions, the solvent is solid and the solute can be gas, liquid and solid. So gas in a solid is the solution of hydrogen in palladium. Liquid in solid is amalgam of mercury with sodium, and solid in solid is copper dissolved in gold. Let's see how do we actually calculate the composition of a solution, like how we can see that how much solute is present in a solution. So an aqueous solution is a solution in which water acts as a solvent, and to express the amount of solute in a solvent, various concentration terms are made. Some of them are mass percent or weight percent, molarity, molality, normality. I'll be discussing some of these in this video. First of all, let's see how can we calculate the mass percent or weight percent, which is also written as W by W percent. Mass percent of a solute is calculated as mass of solute divided by total mass of solution multiplied by 100, and the mass percent of the solvent is calculated as mass of solvent divided by total mass of solution multiplied by 100, where total mass of solution is equal to mass of solute plus mass of solvent. Let's see an example related to this. A solution is prepared by adding 5 grams of a substance in 18 grams of water. Calculate the mass percent of the solute. So here the mass of solute is given, the mass of solvent is given, and we need to calculate the mass percent of solute. So we will use this formula. Mass percent of solute would be equal to mass of solute divided by total mass of solution. So the total mass of solution would be mass of solute plus mass of solvent, and that would be 5 gram plus 18 gram multiplied by 100. So when we calculate this, we will get the answer as 21.74%. Next concentration term is molarity, which is also written as capital M. It is defined as number of moles of solute dissolved in 1 liter of solution. The units of molarity are mole per liter or molar, which is written as capital M, and the molarity is temperature dependent. So molarity is equal to number of moles of solute divided by the volume of solution in liters, and the number of moles of solute is equal to mass of solute divided by molar mass of solute. So the total formula for molarity will become mass of solute divided by molar mass of solute multiplied by volume of solution in liters. Let's see an example. A given solution of NaOH contains 4.00 gram of NaOH per liter of solution. Calculate the molarity of the solution, where the molar mass of NaOH is 40 grams per mole. So the molarity can be calculated as the mass of solute, which is 4.00 gram, divided by molar mass of solute, which is 40 gram per mole, multiplied by 1 liter, as it is dissolved in 1 liter of solution. So when we will calculate it, we will get the answer 0.1 molar. We will put the unit as molar. In the practical experiments, mostly the solutions are measured in molarity. So if we want to prepare different concentrations of the same compound, what we do is we prepare a stock solution. Stock solution means a solution which is prepared in large quantity, and then the stock solution is diluted to prepare different concentrations. So let's see how it is done. Dilution means the adding more solvent to the solution, and when dilution occurs, the molarity decreases. To calculate that how much solvent is to be added to stock solution to prepare a particular molarity, this formula is used, which is M1V1 equal to M2V2, and this formula is used to calculate the volume of water or whatever solvent which is needed to obtain a diluted solution. Suppose we have 0.500 molar NaOH and we want to prepare 1.0 liter of 0.250 molar NaOH. We have a particular concentration of NaOH and we need to prepare this concentration of NaOH, and the volume we need to prepare is 1.0 liter. So let's see how much water we need to add to this concentration so that we get 1.0 liter of 0.250 molar NaOH. So we will use this formula where M1 will be equal to 0.500 molar, V1 we need to calculate, M2 we know it is 0.250 molar because we need to prepare this, and V2 is 1.0 liter. So what we will do is we will put these values in this formula, and that would become 0.500 multiplied by V1 is equal to 0.250 multiplied by 1.0. So when we will solve this, we will get the answer as V1 is equal to 0.5 liter. So this means that we will take 0.5 liter of this concentration of NaOH and we will add rest of the water so that the total volume becomes 1.0 liter. Next concentration term is molality. Molality is defined as the number of moles of solute dissolved in 1 kg of the solvent. For molarity, it was number of moles of solute dissolved in 1 liter of solution, and here it is 1 kg of the solvent. The units of molality are mole per kg, or you can say molal, which is written as small m, and this molality is not temperature dependent, whereas molarity was temperature dependent parameter. So molality is equal to number of moles of solute divided by mass of solvent, which is in kg, and again number of moles of solute can be calculated by mass of solute upon molar mass of solute. Let's see an example. Calculate the molality of the solution containing 8 moles of sucrose in 250 gram of solvent. So we have number of moles of solute and we have the mass of solvent, but this mass is in grams. So we will convert this grams into kg and calculate the molality. So the answer would be 32 molar. Try this question yourself. This question is 100 gram CaCO3 reacts with 1 liter 1 molar HCl. How much CO2 will be obtained on complete reaction? So there is a reaction going on between CaCO3 and HCl, and we need to calculate that how much CO2 would be obtained on complete reaction. What we will do is we will calculate the number of moles of CaCO3 as well as HCl, and then we will compare the number of moles to find that how many moles of CO2 would be formed. To calculate the number of moles of HCl, the formula is molarity multiplied by volume of solution. So it would be 1 molar into 1 liter. So we get the answer 1 mole. Number of moles of CaCO3 can be calculated by taking 100 grams CaCO3. So if we divide this mass with the molar mass of CaCO3, which is 100 gram per mole, we will get the answer, which is again 1 mole. So we have both 1 mole for HCl as well as CaCO3. The reaction between CaCO3 and HCl is CaCO3 plus 2HCl gives CaCl2 plus water plus CO2. Here in this reaction we can see that for 1 mole of CaCO3 we need 2 moles of HCl. So the limiting reagent is HCl here, because HCl we have 1 mole and the CaCO3 we have 1 mole, and the reactant in excess is CaCO3. If 2 moles of HCl give 1 mole of CO2, then 1 mole of HCl would give 0.5 mole of CO2. Now we will convert this mole into the mass. So mass of CO2 would be 0.5 mole CO2 multiplied by 44 gram CO2, which is the molar mass of CO2, divided by 1 mole CO2. So this will give the answer as 22 gram CO2. The learning objective of the topic was calculate the number of solute particles, volume or molarity of solutions. So in this video we saw that what is a solution, what is molarity, and further how to calculate molarity when the number of solute particles and the volume are given, or we can also calculate the number of solute particles if the volume and molarity are given, and we can also calculate volume if the number of solute particles and the molarity of solution is given. Please like and subscribe to the channel Log Iota and press the bell icon